Hello Kickstarter. My name is Mario here, and I'm here to show you exactly the process to which our project is going to happen. Now, like I said before in the video above, we will send you the part files and STL models, and you can also go ahead and download the original IPTs or IGSs depending on what software you prefer for SolidWorks or Inventor or whatever you want to use to actually edit these if you want to. But for the most part, we're going to be sending you an email just the STL files, and these will include the parts like you see right here, where the parts are already laid out in positions for you. So that way it's already done so that there's zero overhang necessary, no need for support material, because our goal is not to have any support material on any of our parts. This way it's easier for the user to go ahead and print, and the prints come out a lot cleaner. Some support material, in a dual head extruder, comes out very well, but for the most part we're trying to keep it as basic as possible, so that way the prints come out, fairly good, no matter, what resolution you're really printing this at. For today, we're going to be using a SolidDoodle 2 with PLA. I don't have a heated bed on this for this print. You could obviously do this in EBS to be fine, but for right now, this is for the 3D printer, and PLA will be just fine. All of our parts right now that we're printing up is the Y-axis motor mount, also 2 corner pieces, and our sliding mount for where the bed will actually be hooked up. As you can see, they're all done for you. It's all one part. This is just the actual base IPT or assembly file right now in Inventor. Just want to show you kind of like in color and what it looks like. But this is what you're going to be seeing. I'm going to go ahead and use the default software for the SolidDoodle. And you can go ahead and use Kira 2 right here. But we're going to be using SolidDoodle base software that comes with it. So right now you're going to go ahead and add your object. As you can see, we have parts 1, 2, and 3. This is for a 6x6 bed. We're also going to have for 6x6, 8x8, and then 10x10 is going to be the largest, and then obviously that one on any printer that goes over 10x10. But 10x10 would be obviously the biggest that you're ever going to need for any of the parts that we are going to be using. We've been looking into doing 4x4s for people that have gotten the older generations of printers. We hopefully will have some of the projects in 4x4, so that way the users can maybe expand and maybe use the 4x4 to print off, an 8x8 print 3D printer, so that way they can move their way up. But for right now, we're looking at just using the smallest right now, 6x6, because we know that all parts can fit on here very easily and are very sturdy. So we're going to go ahead and open up the parts 1 here. It's going to drop in. This way it came out a little bit sideways. No big deal. We're just going to go ahead and correct this by doing -90 on the y-axis. I'll shift it right around. Perfect, it's flat. So we're just going to go ahead and drop it to the base and center it. And as you can see, it fits the 6x6 bed completely just fine. Everything was within its bounds. I can go ahead and show you that right there in Kira 2. Simple file, load model. Find your first parts right there. Drops in. Zoom out. Click on it, and just rotate it around its y-axis 90 degrees. And it drops. And there you go. And the part's are already done for you. Like I said, zero overhangs. Nothing to worry about here. Now the only part is figuring out your layer height, all that kind of stuff you want to do. Most of our recommendations will try and get everything. Everything will be in a 0.3 millimeter height for resolution, which is the most standard across all printers. Obviously, you can go lower, make it finer, but 0.3 would be just sturdy enough, and the resolution would be just fine for you. You can do your shell thickness. I'm doing 0.7 on this, and my infill, I'm going to do about 50. 30 50 is kind of overkill for this, but if you want to make it sturdy, I'm anywhere over 30 is really sturdy enough for a 3D print of this magnitude. The stress and strain really isn't going to be overly that much. But we're going to go ahead and use SolidDoodle's standard software here. I already got it connected. Now we're going to go to our slicer. I'm going to open the configuration, make sure all my settings are okay. Bring that over here. Like I said, 0.3 millimeter. Infill, we're going to go with the 0.3. Like I said, that should be just plenty for this. I'm going to go honeycomb, top fill, infill layer, every layer. Roll 45, seems good to me. Vertical shells, I'm going to do 2. Let's do 2. No, actually, let's do 3 and 3. We'll be working on exactly the exact things. Obviously, be all in your instructions. For the most part, I have the instructions in there. Really, we're just kind of playing around with the settings at this point. Really kind of figuring out like how thick, how dense, that kind of stuff. For the most part, you most likely have used your 3D printer and know what your 3D printer is capable and the sturdiness of what you would like it to be. So ours are just kind of guidelines. Obviously, the user is allowed to pick exactly what settings they want. You want stronger, go right ahead. Everything, like I said, we're trying to leave open source, but we're trying to also make it just like IKEA, trying to make it as simple as possible so that the most novice user can do this, but yet the most professional 3D printer out there could still take advantage of anything in his toolbox to go ahead and make it better. So we're all set there. I'm going to go ahead and save those. Okay. And we're all set there. It's been saved to the 0.3, 6x6 printer. And we're going to go ahead and start slicing that up. And Slicer's going to go ahead. I'm going to let that go ahead and do its thing. And we'll come back once it's all sliced up. Alright, while this is slicing, we're going to go ahead and start the manual controls on here. So I'm going to start leveling my bed out here. Well, already it's already been leveled, but zeroing it out, making sure all my axes, know where the end stops are. And start heating up my extruder. Right now, it's going to 195. I like doing my PLA at 215 degrees Fahrenheit. It's glow-in-the-dark PLA. I don't know, it just seems to print at a good at 215, and it's pretty sturdy. I think around like 200 I've been having it's been a little bit too brittle, so I think the hotter it is, the better that it's going to adhere to the next layer. So we're doing that. That's going to start heating up. We're still slicing. It should be done pretty soon. Most of our parts are very simple for the slicers to go through, but once again, it depends on your CPU and your GPU, how fast it's going to slice it up. As we're waiting for this to heat up still, I'm going to go ahead and mention that all the parts here, like I said in the video, will be open source. It just finished, but everything here will be open source, for even the parts that are being shipped to you. So in the case of the 3D printer that we're looking at right now, I have the print board from my supplier. This one, the one that I'm looking into right now, and my supplier will be able to produce at high volumes. Is saying that I will have an open spot for a heated bed and a dual extruder, so that way if you do want to upgrade, you can go right ahead. For the model that I have up on Kickstarter right now, it does not include the heated bed. It does not include the second head, but like I said, I'm leaving those spots open. I'm not going to take it away. I just want to leave that open so that way you don't have to upgrade the print board. The print board is already upgraded. It's just something you can go eBay, maker.com or something like that and just find the parts. Go ahead and add it yourself. I'm looking into actually making another goal on there. That way I can add in the heated bed and dual extruder as an add-on. But for right now, I wanted to kind of just add in that one for the standard printer with a non-heated bed, because I know that you want to start off small and then work your way up big. Alright, so as you can see, the parts are in here. It looks like Slicer did a good job. Sliced it all good. Looks like a little bit thin there, but that looks just fine to be thick enough. I don't see it pushing through because there's enough support on the sides. So everything looks a-okay here. We're gonna go ahead and check. Looks like our extruder is 175. Go back to manual control there. And I like the push out filament beforehand. This way it starts it going and doesn't kind of like spew out like old material. And you know that the flow of the plastic going through is going to be constant through the beginning part of the print. If you don't do this, what you're going to get is you're going to get like a very light coating of plastic, or not as much as you think that it's going to be coming out of there, and you won't get probably till the second layer the exact amount of plastic that should be coming out of the nozzle, or what the computer thinks that's coming out of the nozzle. So it's good just to kind of give it a good prep, or a prime, I like to say, of plastic through the nozzle. So we're around like 180. It's starting to melt now, so I'll go ahead and kind of force some plastic through there right now. Also, since we're playing with PLA, there is no need for raft here. I got my masking tape down, should be just fine. All of them have very big flat bases to them, so there's no like fine points which would be needed for something of that magnitude of having to have a raft. There's no curved bottoms to them. 215. Alright, we're going to go ahead and run that job. And it's off. Alright, I'm going to go ahead and take this into time lapse. That way you don't have to sit here for hours and watch it. And you'll see the end result, that it fits all in the print bed and that everything is going just fine. You can watch it right now. Guys, so we finished printing. Guess the power went out. It was a little bit unstable last night. Apparently the power went out for like a half a second, which will stop the print. But it did get through all the parts. Basically, I think it was like maybe 2 or 3 layers from ending the code. Everything came out really well. I mean, all the parts came out, okay. I mean, it's what you expect. I mean, just, came out of the computer. It's 1-for-1 mock-up. I did get a little cocky with saying that the bed was level from last time. I did not realize that my front right corner was not completely level, so that did give me a little bit of a rounded edge on the thing. It peeled up a little bit. But besides that, I mean, everything else came out. I mean, the top layers came out fine. Like, as you probably already know, if it becomes a little bit too, not level one spot, a little bit too high and doesn't adhere as good as the rest, it will, start to pull up. Even though PLA doesn't shrink as much, it does shrink a little bit. I mean, the part is completely usable. Nothing wrong with the hole is on the opposite side, so, everything's completely alright with it. And it was just the one part that was affected by that. But I mean, everything else came out completely fine. All the holes are completely, symmetrical, and it's all good. I mean, it's what you expect. I could have probably printed this at like 20%, maybe even 10, because really these things are really dense. I didn't think that the 30% was going to be that dense. We've been messing around with going from even 50 and then down. We thought we'd try with a 30 this time, thinking that, drop it down by 20, but I mean, even with this, I mean, it's ridiculously tough. So, probably gonna put the recommended down as probably around even 20, maybe even 15. I mean, because these are big parts, and, when you're working with bigger parts, they have a little bit more structural integrity than you would with a smaller part where you probably would want, a more dense part for a thinner area. But I mean, in these cases, I mean, they seem to be pretty sturdy. So, I mean, no real necessary need for that dense. The rest of the tutorial will be emailed to you. For right now, we just wanted to kind of show how you would get the parts emailed to you and printed, and showing that it's a feasible thing. I mean, for the most part, everybody knows that it is feasible. I mean, this has been done on Thingiverse all the time. Our basic concept is that we're trying to have everybody print off the same parts with using the same parts being shipped to them and putting it together. So everybody's kind of working together to build the same machine and the same concept. That way we can all work together. If there is something that you may be tripped up on and the instructions didn't get to you, I mean, you have a whole body of people who have been working on the same exact project. So there's no like with the concept I've been running into when I built my first 3D printer is that I got all my parts in and then I started to actually build it, and the issue is that even though it came out to be the same thing, using the same type of frame and the structure, maybe the same even parts I printed off from Thingiverse or whatever, I kind of ran into a stalemate when one person would use maybe a little bit bigger motor. Even though the concept is the same, sometimes the parts didn't fit into what they designed, and then that's what I had to go in and try and find the original model, figure out how to turn an STL file into a regular file, and then have to kind of, remodel it to fit the parts that I needed. The whole idea of this project is that all that has been worked out for you. The parts that you're getting are going to be working together with the parts you print out. There is no trying to mess around the model. Like I said, though, we've left all original file formats for the user to use. So if you feel as though you want to go ahead and change it, you are more than welcome to do anything with any of our parts. It's all open source. We're holding back nothing from the user. So if you want to go ahead and take our original files, let's say add another Y-axis or whatever, or you find that you want to use a bigger motor, make it more powerful, that is all up to the user. We're not going to hold you back from changing anything. If there's any files or anything we can help you with, obviously email, and we'll be more than glad to send out any information about any of our parts. One other thing I think I did accidentally mention last time, that this was for the motor housing for the Y-axis. That was a mistake. This is the opposite side. The reason why is because it doesn't have the actual cutout groove for the wires that go through it. I just used, we modeled one side for the Y motor, and we just kind of used it for the other side too, because we needed the bearing outlet at the top, and we didn't feel as though it was necessary to go ahead and change everything, so we kind of left it looking the same. So I kind of got a little confused there for a second with the model. But For the most, this is just the other side. So if you're wondering why there isn't a hole for the wires to go through and mounting holes for the motor, that is why. It's just for the other side. That's all. But for the most part, I mean, this is what you're going to come to. You're going to print it all off. You're going to go ahead and take our instructions, put it all together, and basically you're only paying for the parts you need. I mean, we're trying to turn every house into a little mini factory here. I mean, isn't that the goal of a 3D printer? To print off exactly what you need and, and only pay for what you actually need. So, just trying to make your life a little bit easier. Hopefully you can see that, and hopefully you guys can go ahead and start, help me fund this Kickstarter and, purchase your project packs. I mean, even with this 3D printer, I mean, it's 8x8 3D printer for for a reasonable price. I mean, with that, I mean, I believe that after you build it, it's worth far more than what you paid for it. So, you can go ahead and just turn that around. I mean, you can turn your own mini factory and make a profit off of it. So if you want to go ahead and order our parts, or whole package, you get the parts, you get the diagrams, whole 9 yards, and you go ahead and just turn it around. Make yourself a profit. I mean, you do it again with the quad rotor. I mean, you're really turning, quite a bit of profit with this. So, I mean, for any cost, I mean, you can do really anything with our project packs. So I hope this really helped you to kind of see from point A to point B of how all this is going to work. If you have any questions, please write me in the comments. Please back us and help us fund this goal. Thank you.